So today's video is going to focus on our third learning target of the semester, distinguishing between speed, velocity, and acceleration. But we're really just going to focus on speed and velocity and what that means and how to calculate it for right now. So the first thing I need you to do is take out your green unit organizer and label in section 19 speed and velocity, notes, and IP. And you're actually going to get 10 points for this. Now I need to find this section in your binder. You're going to label at the top right hand corner 19A. Now when we talk about speed and velocity, the first thing we need to think about is what is motion? What does that even mean? And motion is a change in position relative to a frame of reference. Okay, that's great, but what's a frame of reference? A frame of reference is something that is fixed in place which means it's not moving. So we can see where motion begins and ends. Now, speed and velocity are kind of the same thing, but let's talk about how they're similar and how they're different. Speed is the amount of distance traveled in a set amount of time. Velocity is the same thing as speed, except it has a specific direction, and it's called a vector quantity. To sum it up in one sentence, velocity is speed with direction. Now there's two types of speed/velocities that we need to think about. One is called instantaneous speed and the other one's called average speed. So average speed is how fast an object is traveling over a period of time. An example we use in class quite often is how fast a car, like in our car and ramp experiments, goes through 2 photo gates. Instantaneous speed, however, is how fast an object is traveling at a particular moment. So for example, using the car and ramp setup, it's how fast a car goes through, sorry, that's an R, 1 photo gate. Calculating speed and velocity is really important, and to help us, one tool we're going to use is called a formula triangle. And our speed-velocity formula triangle should look like this. V is going to go in the bottom left, little triangle D is going to go in the top, and then little triangle T is going to go in the bottom right. This little triangle is called delta, and it's a Greek letter, and it means change. Well, what does all this mean? Well, V stands for velocity, or speed. It's the same mathematically. We just have to remember that velocity has a direction while speed does not. And they're typically in units of meters per second, kilometers per hour, or in the English world, miles per hour is a really familiar one. Delta D stands for the change in distance. And some common units there are going to be meters, kilometers, or miles. Now delta t, I'm sure you figured out by now, means change in time. And some common time units are seconds, hours, and minutes. Now, say we need to solve for speed and velocity. How we're going to do that is, if you had this on your paper, you would put your thumb over the v. So if you put your thumb over v, all that's left is d over t. So if you need to solve for speed or velocity, you're going to need to be given distance and time. In your equation, so we say v is equal to delta d over delta t. So delta d over delta t. This is going to be division. Say we need to solve for distance. So we would cover up the d with our finger, and we're left with v and t. So with the variables we'd have to be given are velocity and time. So the change in distance would be equal to v, and then it's next to t. Now if two variables are next to each other in our triangle, that means we're going to multiply them. So the change in distance is going to be equal to velocity times the change in time. Put a little note to ourselves that we're going to multiply, but they're next to each other. The last one, if we need to solve for time, we would have to be given distance and velocity. So our change in time is going to be equal to delta d over v. So our change in distance divided by our speed or velocity. Put a note to ourselves that we're going to do some division there. On the back side of the page, you're going to see 5 guided practice problems. I'm going to do the first 3 with you. When we do problems like these in physics, and we're going to have a lot of them, there's a specific format I want you to follow. First, you're going to read the problem to yourself once without marking anything. So, what is the speed of the cheetah that travels a total of 112 meters in 4 seconds? Now you're going to read it again, but this time you're going to circle what you're looking for. So what is the speed of the cheetah that travels a total of 112 meters in 4 seconds? It's asking for the speed, so I'm going to circle that. And that second time you read it, you're also going to underline what you're given. So I'm given 112 meters and 4 seconds. If it's 112 meters, I need to think to myself, meters. That unit means it's a distance. And 4 seconds, and I know seconds is a unit for time. So I've just done the hardest part. The next part is actually finding out what formula to use. If we're looking for speed, we can go to the front side of the sheet and say, okay, we need to solve for speed/velocity. We were given distance and time. So I need to use this equation right here. So the equation I'm going to use is v is equal to delta d over delta t. So my distance was 112 meters divided by 4 seconds. I'm going to take out my handy dandy calculator. 112 divided by 4 equals 28. Well, what's my unit? If it's a speed, it's going to be distance per time. And our unit for distance in this problem was meters per, or divided by, and our time unit was seconds. So our answer for the speed of the cheetah was 28 meters per second. The second problem asks, remember the first time we read a problem, we don't mark anything. A bicyclist rides 60 miles in 3.5 hours. What is the cyclist's average speed? Okay, now that you've read it once, you should read it again and mark stuff. So you're going to circle what you're looking for and underline what you're given. A bicyclist rides 60 miles in 3.5 hours. What is the cyclist's average speed? So I'm looking for speed again. So I can actually just look up to the problem above here and say, okay, I'm going to use the same formula. So velocity or speed is equal to the change in distance over the change in time. My distance, if I look back to my problem, I need to figure out which one's which. Well, I know hours is a unit of time, so I'm going to assume this is my time unit. And I know miles is a distance, or length, so I'm going to mark that as my D. Now I'm going to plug these numbers into the formula I chose. So if I have 60 miles traveled in 3.5 hours, I would have an average of 17.14 miles per hour. The last problem I'm going to do with you reads like this. Remember, the first time we read something, we don't mark it. What is the average speed of the car that travels 300 miles in 5 hours? Now remember, the second time you read it, that's when you circle what you're looking for and underline what you're given. So what is the average speed, looking for this, of the car that travels 300 miles in 5 hours? Now miles is a length, so I'm going to assume that's my distance. Hours I know is a unit of time, so that's going to be my time. I'm still looking for average speed, so I'm going to use the same formula I've used in questions 1 and 2. So V is equal to the change in distance over the change in time. So 300 miles over 5 hours. That's going to equal 60 miles per hour. For class on Friday, I want you to do numbers 4 and 5 on your own because those will show up as warm-up questions. Be sure to circle what you're looking for and underline what you're given because they might not be the same type of problem we just did in guided practice. Remember to use your notes and try your best.